So now I'm going to switch over to debugging, and we're going to make use of some of these things like PyLith info and the help components. These examples are in example/debugging. There's 3 steps. We probably will only have time for steps 01 and 02. The correct files are in the directory correct, but I suggest you don't look at those at this time, because we will be able to go through them, and it's a good exercise to actually try and figure out what the errors are. And so if we don't have time to go into step 03, I suggest you, as a practice, try running step 03, and then when you encounter the errors, try and debug them, and then if you get stuck, you can look at the correct files in the correct subdirectory. So let me switch over to the debugging directory. And before I actually run step 1, this is just a simple shear using a Dirichlet boundary condition in a static simulation. So that's the type of simulation it is. So we'll just assume that we think we've put it all together correctly, and now we want to see. We think we're ready to go, and so we run the problem, and this is what happens. So let me clear my screen and run it again so we can just see what the error message is. So this is what a Python level error message looks like. So Python, when it runs into an error where there's an exception, it shows a backtrace. It calls it a trace back, walking down the hierarchy. So here's our top level. It's at the PyLith application. Then it's down here in the running within the shell. That's the Python shell. In the application, it's applying the configuration. And there was here is the exception that was thrown. It was a value error. And this is my error message here. And it says error while configuring the Dirichlet boundary condition, which was a Dirichlet BC xpos, error while configuring boundary condition. And then it says label for group node set, pset, and mesh not specified. And it also then gives you the hierarchy that it was walking down to get to x positive. So this looking at the hierarchy is very instructive, because it really helps you identify if you have multiple spatial databases, multiple boundary conditions, or multiple output specifications, which output specification it is, or which boundary condition it is, or which spatial database it is. So in this case, I see that it's PyLith app, time dependent, or problem, BC, X positive. So let's go, and the thing we're going to look at is label for group node set, pset, and mesh not specified. So we're going to switch to debugging step 1. And so let's see, I said I was down in xpos. So here's my boundary condition, here's xpos. And here's where I say xpos, but you can see I have a typo there. That instead of xpos, it says xposx. So none of these, the settings seen here, were not applied because I had an error in the label of where I was in the hierarchy. So I will fix that, save it, and we will run again. Okay, I still have another error. So this time it says I am at step 01.cfg line 99, and I have a says unknown component, PyLith app time dependent implicit output solution right. So let's see here. If I go back and go to line 99, here I am, and look, I can see on the next line I have another typo. Instead of writer, I put right. Oops. So that was the case of a that was a validation error, or in well, not a validation error. Is in sort of essentially a parsing that I gave it an object that it did not know what to do with, and so it gave me an error. So let's run it again. So now I have gone past Python, and now it's been buried down into C++. And I can tell that because I have now buried myself down. It's running a module, and it's down here, and I have a runtime error which that is down in C++ code. So there's a question: can we use echo in script? I'm not sure what you mean by echo.
So Brad, he means, can you put a print statement in the script?
So you can put print statements in the Python code. It means you have to then rebuild the Python code. You can't put print statements in the .cfg files. And the PyLith binary does not come with the debugger. And it's optimized code, so the debugger doesn't work that well. If you want to drill down, generally use the debugger to really trace through the code, we strongly would recommend building from source.
Yeah, I guess what I would say too is that what is in the CFG file is purely data. There's nothing being executed. So the PyLith info is a good way to see what data has been read in, and you can compare that to your file. But nothing's being executed, so you would not want to put a printf in that place.
So back to our error here. So there was an error reading the spatial database file matelastic.spatialdb. And additionally, we were told IO error while reading simple DB data. So by saying it's reading the simple database data means it is read past the header, and there's a problem with the actual data. So let's open up matelastic. And I see that I have one line of data. I have 3 coordinates and 3 values. So I was expecting 3 values, so that's good. I am in, well, we'll see one place that has space dimension 2, one place space dimension 3. So I don't actually know what spatial dimension I'm actually in. But it also says that I am expecting 3 locations, but I only have 1 data point. So clearly, I know at least one error is that the number of locations should be 1. So I don't know what, I haven't actually said what space dimension I'm in. So we'll see what happens if we leave that ambiguous. And so, okay, we have again an error in spatial database file matalastic.spatialdb. Number of dimensions in coordinates of spatial distribution 2 does not match number of dimensions in coordinate system 3. So it looks like the 3 is correct and the 2 is incorrect. So let's switch it to 3. So we have space dimension 3 in both our coordinate system. And let's run it again. Okay, we have another error. And this time it says, found overly constrained point while setting up constraints for Dirichlet boundary condition face C negative. Numbers of degrees of freedom at point 503 is 3, and number of attempted constraints is 4. So what this means is I probably constrained a degree of freedom in multiple Dirichlet boundary conditions. Since I know my space dimension is 3, so I know the maximum number of constraints that I can have is 3. And I have attempted to apply 4 constraints. So I need to look at my boundary conditions. That's back up here in step 01. Here are my boundary conditions on the screen. So my x pos degree of freedom, I've constrained 1. X negative, I've constrained 1. Y positive, I've constrained 0 and 2. Y negative, I've constrained 0 and 2. And the bottom, I've constrained 0 and 2. Well, so I've constrained z degree of freedom on both the y positive, y negative, and z negative faces or boundaries. So generally, you would want to constrain only. I'm guessing that I wanted to constrain the x degree of freedom on my y boundaries, since I do have a z boundary. So let's try that. And so it ran. And let's see, it did it right. Output. It wrote output. So let's look at it in peer review. Always a good idea to look at your output. Here's our box. Let's look at displacements. Let's warp it, let's say by a factor of 1,000. Yeah, that wasn't very much. How about 4,000? So it looks like I am shearing it. Let me put on the displacement vectors. What did I say? 2,000? We'll go up to 5,000. And I need all points. So there we go. Yes, I am shearing my box. So you can see that how I have, I've sheared it by on the Y face giving an X degree of freedom. Sorry, that's on that X face and Y faces, I've given it Y degrees of freedom. On the Y and Z, I've given it X degrees of freedom, and then I gave it a roller boundary condition on the bottom. So you can see the displacement field. That looks like what I expect. If I look at the warp vectors, I can look at the X displacement, nice linear variation. And the y displacement, nice linear variation. Z displacement is 0. Just what I would expect. So we successfully have run step 01. So that looks good. Any questions on how we did the debugging and how we sort of walked down through the hierarchy to try and pinpoint where our error was?